So hello dear, welcome back. Hope everybody is doing fine, and we are almost at the frag end of implementing the Bayes classifier, and just try to recapitulate. And I believe that today also you are with pen and paper. Try to recapitulate what we did. We first discussed the theory associated with Bayes classifier, three algorithms we have learned, and then we are implementing one algorithm which is most common one, and telling how to implement the other algorithms as well. And in that process we are actually going to predict. Actually we uh, had taken this small problem which can be doable by hand with just 30 messages. Okay, it could be emails or Twitter or any other social media messages, 20 of which are normal messages and 10 are spam mail. Okay, and then we created a small vocabulary because we'll have to do it by hand. 5 vocabulary we created, and then all the steps we were showing. And it turns out that Bayes is very much susceptible to zero probability. In fact, it will crash because you have seen that apparently one spam mail, the probability of being in the class spam will be always zero if any of the word associated, okay, with the mail has zero probability in that class, in spam class. So we try to avoid that by so-called labeless smoothing, and here is that for recapitulation. After labeless smoothing, we need to recalculate the probabilities. Okay, these were earlier probabilities, now everything has changed. So 21 by 45 will be the probability of hello, or seeing that word hello in the class normal, like that. 16 divided by 45, so that we did in my earlier lecture. Okay, so once you have made all the recalculated probabilities, now see what happens. Then the model is ready with Laplace smoothing. Now the model is more smart. Okay, it is with Laplace smoothing. So now let us see how prediction can take place in this new paradigm after doing Laplace smoothing. So our new message or mail, what we receive is hello, got lottery money. Okay, so now prediction. For predicting, I will have to just test what is the probability that, what is the score of this sentence in my normal class. Okay, so given the sentence, so that is equals to, we already have the model. So what we'll have to do, we'll have to calculate to figure out the score of this to this class. We'll have to calculate this one. Okay, and then j equals to here 1 to 1 2 3 4 words we have, right? So Okay, so this is what we need to calculate. So prior probability, as you have seen, it will never change. Before Laplace smoothing and after Laplace smoothing, it will not change, and all other will change. So probability that hello being in normal class times probability of so this is got, right? So probability of got times probability of lottery given it's in normal class times probability of money, and then you need to just put these values from earlier lecture, hello is 0.47 after Laplace smoothing, of course, 0.067 times 0.04 times 0.067. That turns out to be, this is equals to 0.40123457. So you are with me, you are calculating with me. So so probability that the hello got lottery money is proportional, the score is proportional, the sentence has a score for belonging to a class normal, score is 0.123457. So similar, I need to calculate the score in the spam class. Okay, that is that again can be calculated from this. Here j equals to 1 to again 4. Equals to spam class, and that turns out to be 0.33. Prior probability has not changed, okay, times same as before, sorry, this is spam money. Okay, and just put the values here. Okay, turns out to be, so you are working with me, so no problem, you can correct me. 0.04 times 0.36 times 0.24, which turns out to be 0.00027. So this is a new score here, and things to be noted that now, so this is the probability value with Laplace smoothing which we have achieved, right? And it is saving our model from crashing. Now you just calculate arc max over y given x, okay? So this is equals to, that is, the message belongs to spam. Great. Because you see, this is how many times at least separation is very wide, okay? This is 1/5 almost of this value. So this is 5 times greater than this. So earlier it was the same message actually was classified in this category, normal category, which was wrong, and this was 0, okay? Score was 0, and it would remain 0 as long as any of the probability value is 0. So we could avoid that using Laplace smoothing. So that's a great achievement you have done. So now your classifier is robust, and it could classify your message appropriately. So with this, you see, the Bayes classifier is actually a very good classifier, and you know, this is simple to build, and although it is a little bit dirty, but you can clean it up by scaling it up with more data and all. But since it is very easy, many people, they first hand use this Bayes classifier. And you know by this time that how it is called naive, because you see, deliberately I was putting this colon and then note of exclamation, and those have no meaning to our Bayes classifier. Even the words, the order of words has no meaning. If I would write lottery, got, money, hello, okay, any order if we make, the probability value, if they interchange, is not going to change. So classification will not change, although they are now meaningless sentences, right? So Bayes never try to understand the semanticity of your sentences, but even then it does a very good job in classifying the messages appropriately. So one of the reasons that it is called naive is also that it is working in a stupid way but giving you a very effective result, okay? And it ignores all the relationship of the words, right? So it is, normally we communicate following some grammars, following some rules, right? Since it is ignoring all the rules, because if some rules and grammar has to be followed, then the analysis would have been much more complicated, okay? Then of course it could have, naive could have been avoided, but till then, since it is working well, we don't care about grammar, order and all kind of things. So it's just considered, Bayes classifier consider your words, 20,000 words, 10,000 words, whatever it is, a bag of words, right? And whimsically you collect, and the messages to the Bayes classifier is nothing but some words from the bag, okay? Ordered, then punctuation, grammar rule has no meaning. So that means in machine learning language, it has high bias and low variance, That's the reason that actually um, it works pretty well. It has low variance, huh? So that's why it fits well in the task for which it is developed. Okay, so with this, I believe you have understood the undernet principle on which the naive-Bayes classifier works, and you will be able to now develop your own model right from the scratch, because you know both algorithmic way of working, theory, algorithmic way, everything you know. And I hope that the videos will be effective. It has wide application, you see, in text classification, okay, spam filtering, sentiment analysis. Okay, and customer sentiment matters a lot for many enterprises. So it helps in business. Okay, it helps banking sector for fraud detection. It helps in creating a recommendation system. Okay, for movies and all kind of things. So so that creates advertisement more profitable. And one more thing is that it can be also used for multi-class prediction, because you see argmax function which you have used, it is merely computing the score of of the entity from different classes, and whatever is the high score, it classify to that class. Okay, okay, whatever class the particular entity score high, it classify in that class. Okay, so it is easily can be used for multi-class prediction. And then it can be used for real-time prediction. Real-time is actually in robotics paradigm, real-time means 0.1 millisecond. Okay, if action can take place within that, sensing and acting can take place within that, then it is real-time. So since naive-Bayes is very quick, it can make real-time prediction, and that may be useful in some application, like robotic application. And it is highly scalable and efficient. Okay, say you are using now 30 mail or messages, and then you can easily extend it to 3,300 mails. Okay, because all it is doing, you know, I have tried to show you through indicator function. Okay, that all is trying to calculate is the frequency. Okay, and that is very fast. Okay, and there is no gradient descent algorithm. Okay, no iterative process here. So that's the reason it is very, very fast. So with this, we have talked many things about, good things about naive-Bayes classifier, but in machine learning, there is no free lunch. The oversimplicity has some limitations. Okay, it is rough. Classification initially may not be great, but you can scale it up, make it more efficient, and you can add more module to it. Okay, so that the primary level you classify using Bayes, and then you switch over to other thing, logic or other classifier to get more precise result. So you need to embed more modules to it so that it can work efficiently. So this is about naive-Bayes. I saw many of my students were doing semester project while we were evaluating you in the mid-semester, and they were doing projects on naive-Bayes classifier. But when some fundamental question we asked, they could not answer. But after undergoing this video, I believe they will be in a better position to do their projects. And now we will give you assignments, and in the discussion forum, we will discuss all about the video lectures which we have created for you. Okay, and for further reading, I have already referred that Coursera, we have actually used Andrew's formulation of that indicator function, which is very useful for you and very easy now for you, and with an objective that you will feel comfortable in future. Some of my students may go to Stanford, and he was earlier teaching in Stanford. Many of our students actually graduated from Stanford. So at least you will feel comfortable in communicating. You know some basic things. So with this few words, I wish you all the best. Stay safe and have a nice day. Goodbye.